This is your Unit 3 review for the paper part of the test. And so we need to pay attention to whether we are not allowed to use a calculator or whether we can use a calculator. So this first part is no calculator. So you can use your list of squares and cubes to help you, but you do need to know how to do this stuff without a calculator. So first group, we are factoring. So what we are looking for is we are trying to find a common factor. We don't see one, so this means we're going to have to do slide and divide. So that means I am multiplying. Now, 18 times 5 is not one that I just know right offhand. 8 times 5 is 40, and that is 90, right? 45, yes. Okay, so this is going to become x squared minus 27x minus 90. Okay, so this isn't the most friendly set of numbers to work with. Hopefully I'm not gonna, okay, so we've got 1 and 90 because what we're looking for is what's going to give us negative 90 that would add to give us negative 27. So I've got 2 and 45. I've got 3 and 30. Oh, okay, well that's easy. So, because honestly, I was kind of freaking out when I was seeing those numbers. I was like, oh, those aren't nice numbers to work with, but that's not bad at all. They were easy factors to find and, nothing too crazy. So when I am factoring this, this is going to be x plus 3 x minus 30 because I had to make sure the signs worked out because when I add these together, I'm supposed to get a negative 27. Now, remember, you guys do really good at the slide part. You always forget the divide part. So let's divide both sides by 5 because that's what we multiplied by. And so 3/5 will not reduce. And so instead of writing it like a fraction, I'm going to bring it out in front. So that's going to be 5x plus 3 is one of the factors. And then x minus 30, well, 30 divided by 5 will work, and that's going to be 6. So x minus 6. So this factors to 5x plus 3 times x minus 6. Do not let numbers you're not familiar with scare you. Okay? All right, well, look at this one. We've got a trinomial. We do not have any GCF. We're going to have to do slide and divide again. Now, these numbers don't scare me as much. 3 times 7 is 21. So really, I'm going to come up here and do some work. So when I multiply, I get x squared plus 4x minus 21. And so I'm trying to figure out what's going to give me 21, negative 21, that would add to give me 4. Well, we've got 1 and 21, 3 and 7. And so we can tell then it's 3 and 7. So what is the combination with the signs? Well, I'm supposed to multiply to get a negative, so I know one of them has to be negative. But when I add, the sign is positive. So that means 7 is positive and 3 is negative, because that's the way I can get positive 4 when I add. So when I do this, I get x minus 3 times x plus 7. Remember, this is just my helper. I'm not done yet, because what we forget to do is divide by what we multiplied by. We did the slide. Now we have to divide. So I can simplify this. 3 divided by 3 is 1. So one of my factors is x minus 1. I cannot simplify 7 over 3, though. It won't reduce anymore. And I don't want to write it like a fraction, so I'm going to put 3x plus 7. So there we go on that one, too. All right, number 3. So when you look at this, you see we have 16 as a square number, x squared is a square number, and 25 is a squared number. So this is the difference of two squares. Hey, we know how to do that. We've done that for a long time. So the square root of 16 is 4, the square root of x squared is x, the square root of 25 is 5. And so those are our factors, and so we make 1 plus and 1 minus. There we go. All right. And we always ask ourselves if we can reduce it more. And of course we can't because there's nothing that we can do with that. All right. Now let's get into simplifying. So we are simplifying. Now we are adding or actually subtracting these. When we add or subtract, they have to have the same radicand, the same number underneath the radical. And so obviously they don't now, but we need to try to simplify them. We are doing square roots, so I'm trying to find a perfect square in 72. I know 9 times 8, but I also know, let's see, 72. Okay, let's do this. Because I know 9 times 8 would give me 72, but actually 36 times 2 would be the better one. Because if I did 9 times 8, that wouldn't simplify completely and I'd have to simplify again. It wouldn't make it wrong, it would just make more work. So I can take the square root of 36, that's 6, and so 3 times 6 is 18, so this becomes 18 square root of 2, okay? And then square root of 32, well, let's do this. So 5, 32 would be 16 times 2, right? And I can take the square root of 16, that's 4. So 5 times 4 is 20, and square root of 2. So now I have 18 minus 20, because they're both square roots of 2, so I can combine them. So 18 minus 20 is negative 2, square root of 2. All right, number 4. Now we're multiplying. You can multiply numbers. They don't have to have the same radicand. Okay, so what I would do in this case, now you can do it however you want, but I noticed that these numbers, like, they don't really simplify on their own. Actually, they kind of do. Some of them do. So if you want to multiply first and then simplify, the numbers aren't going to get too big. Or you could simplify first and then multiply and see if it'll simplify. Since these numbers are kind of small, I'm going to multiply everything first. Now remember, you can multiply the numbers on the outside, which is just a 1 and a 2. So 2 is going to be on the outside. And then we multiply everything, all the like terms together on the inside. Well, I can do 12 times 3, and that's 36. M to the third times m would be m to the fourth because we add exponents when we multiply. And then n squared times n to the fourth would be n to the sixth. Okay, so let's go ahead and break this down some more. So we're trying to find a square factor that lives in 36. Well, I've got oh, wait. No, I don't. 36 is a square factor. So I'm going to leave 36 alone. And if you used your list of squares and cubes, you would see that 36 was on there. And then we are trying to take the square root of these numbers. Now remember, on a square root, the index is 2. And so when we're dealing with exponents, what we're really doing is just dividing by that exponent. And so can I divide 4 by 2? I can. So in a moment, I will be able to completely take the square root of m to the fourth. Can I do n to the sixth divided by 2? Yes, I can. And so now, I actually ended up rewriting it exactly the same, but what I was trying to do was break it into its square factors if I had to. And so it just so happened that everything this time I can take the square root of. Okay, so you may have thought ahead and not had to write it again, but that's okay. All right, so square root of 36, I can bring that out. So that will be 6. Okay, remember I'm multiplying this 2 by the things that are coming out. M to the fourth means I'm dividing by my index, so 4 divided by 2 is 2. So m squared, I'm just going to write it down. 2 times 6, I can do that, that's 12. M to the fourth, when it comes out, is going to be m squared. And n to the sixth, that would be 6 divided by 2, which is 3. So it's going to come out as n to the third. There is no leftovers in this, nothing that still is belonging under the radicals. So we're good. All right, number 2. Or these numbers are so weird, so just follow along the best you can. All right, so this one here, we have I to the ninth, and all of our directions are just telling us to simplify. So what do we know to do with this? Well, if it's just I to the ninth, that means we need to break it down into its lowest form of what the I equals. And remember, it goes I, -1, negative I, 1, right? Because I is I squared is -1, I to the third is negative I, and I to the fourth is 1. So if you can think about every group of 4 that I can take out of here is equal to 1. Well, I can take 2 groups of 4, so that would be 8, right? So I have I to the 8th, and that would leave me with 1 more I. Well, of course, I to the 8th is just going to equal 1. And so 1 times I is I. That's it. Okay. All right, number 5, we are dividing, and you can see that we've got radicals in there. And just like we learned with our i's, we don't like radicals in the denominator. So what we're going to do is, since this has a plus sign or even a minus sign in the denominator, we have to multiply by the whole thing. And we're going to multiply by the same terms, but the opposite sign. These are called conjugates. Whoops. So we are multiplying numerator and denominator by 2 minus the square root of 5. Okay, now I'm going to write it bigger so you can see, because what that really means I'm doing is I am doing 2 plus the square root of 5 times 2 minus the square root of 5, and then I am multiplying 5 times 2 minus square root of 5 in the top. So if you can do that in your head, or not necessarily in your head, but if you can do that without writing it again, that's fine, you can do that. All right, so I am going to distribute 2 times 2 is 4. 4 times, or 2 times negative 5, negative square root of 5 is negative 2 square root of 5. 5 times square root of 5 times 2 is positive 2 square root of 5. And square root of 5 times negative square root of 5 is just negative 5, because remember that would be square root of 25, which is 5. Okay. All right, so if you do it right, all the conjugates, those middle terms should cancel out and get rid of the radical. That's why you do that. And so I'm left with 4 minus 5, which is negative 1 on the bottom. Okay, and then let's go ahead and distribute. So that's going to be 10 minus 5 square root of 5. We cannot multiply 5 times 5 because 1 does not have a radical and 1 is under the radical. So this is the best we can do. Okay. And then, so we can't simplify that. So if I just move that over, okay. Now, what I notice is that we've got this, and technically this is not wrong, but if all that's left is a negative 1 in the bottom, that's just going to make this entire thing negative. So be careful, because that's going to make it a negative 10, but that's going to make this a positive 5 square root of 5. So you have to make sure you've taken care of that, because that makes the whole thing negative, which changes the signs. Okay? All right, number 3, you can see we are multiplying. So we have a monomial times a binomial. So we're just going to do some really quick distributing there. So we've got negative 48i squared and minus 6 times 12 minus 72i. I know I squared is negative 1, so this is positive 48. And so I have 48 minus 72i. And we need to always check and make sure that it is in standard form. Standard form means that the I part comes last. Also, the same thing with like radicals. Like the radical part should come last when we write it in standard form. So it's in standard form. There you go. All right, number 6. So I like to break things down as I can in the parentheses first. Now, this is one where you might do things differently, and that's absolutely okay. It's completely up to you. But this is kind of how I think things through. And actually, no, I'm going to do it the other way. So sometimes when there's not too much going on in parentheses, I'll just go ahead and take everything to the power of 2, because we know that that's what we're doing, right? Like everything in here goes to the power of 2. So 8 to the 1/6 goes to the power of 2. M to the negative 2 goes to the power of 2. That's it. Okay, now we do have to simplify it further. Of course, when we take powers to powers, this would be 8 to the 2/6, which 2/6 is 1/3, and this would be m to the negative 4, right? Now, simplify some more. What can we do? Well, I know that 8 to the 1/3 is the same thing as the cube root of 8. And I'll simplify that in a second. And I know that m to the 4 has to come down here to become m to the positive 4. Now, I'm almost done, because remember, we've got to simplify. Now, if I just got variables in there, I may not be able to do things with variables, but I have a number in there. And so can I take the cube root of 8? Yes, I can. It is 2, and we've got m to the 4th. So that's my answer, 2 over m to the 4th. All right, number 7, we've got some that we're adding and subtracting, and so of course we know they have to have the same radicand, the same number under the denominator. So let's break it down. Well, I can't do anything with square root of 5, but I know that square root of 45 is 9 times 5. And so I can take the square root of 9 out, and that's going to be 3. And I know the square root of 20 is 4 times 5, so I can do the square root of 4, which is 2. All right, so I just kind of simplified it right there in that step. All of these are square roots of 5, so now treat them just like variables, right? I'm not doing anything with the square root of 5. It just tells me that I can put these together. So 5 minus 3 is 2, and 2 plus 2 is 4. So 4 square root of 5. Boom, that's it. Okay. All right, here we have another one. We're just simplifying it into, the cycles of I, like I call it. So if I've got I to the 10th, remember, we're trying to find cycles of 4 or groups of 4 because every group of 4 I's means it's equal to 1. So I can look at this as I to the 8th because that's 2 groups of 4, and I know that's going to be 1. But then that also means I've got 2 I's or an I squared left over, right? So we know that I squared is -1, so I have 1 times -1, which is -1. I put it in parentheses, you don't have to, it's just habit. Okay? All right, next one. Got some multiplication here. 3i times 9i is 27i squared, which is -27 because I squared is -1. I don't like i's in the denominator, just like I don't like radicals in the denominator. So this one has a plus or a minus in the denominator. So I'm going to have to multiply by the conjugate. So this is going to be 1 minus 3i. 1 minus 3i. Now I write bigger so I don't make mistakes, because if I try to scrunch it up, sometimes I get messy. So 1 plus 3i times 1 minus 3i, and then 8i times 1 minus 3i in the numerator. Okay, so 1 times 1 is 1. 1 times minus 3i is minus 3i. 3i times 1 is 3i. And 3i times negative 3i is -9i squared. All right, those canceled out. That's what we expected to happen because minus 3i plus 3i goes away. And this is going to be +9 because -9 times -1. So what's left in my denominator right now is 10. And so let's go ahead and distribute this. So this is going to be 8i, and this is going to be minus 24i squared. And so that is going to become, this is be positive 24. So that's a whole number. Now it's got to come in front. So we've got 24 plus 8i. Now, remember, we're going to simplify this some more because when it looks like this, we need to break it apart. Okay. Because it's not, there's like a plus or minus in the denominator or in the numerator now that we can kind of break apart a little bit more. And so I'm going to look at this as 24. I'm going to come up here because otherwise I'm going to run out of room. Okay, so it's going to be 24 tenths plus 8 tenths I. Now we can simplify that. 24 divided by 10 simplifies to, if I divide by 2, that's 12 over 5. And if I divide by 2, that's 4 over 5. So my final answer is 12 fifths plus 4 fifths I. Okay, look at number 11. Now, number 11, this is the one I'm talking about. Like, there's a lot going on in here. So before I take everything to the third power, I'm going to simplify a lot of this stuff in here. Now, you can do you can take 7 to the third, a squared to the third, b to the fifth to the third. You can do all that if you want. I'm going to simplify my denominator first, or my fraction inside the parentheses. So 7 over 42, that really means that's going to reduce to 1/6, which means my 6 stays. I could write the 1 if I wanted, but I know there's going to be more stuff up here, so I don't have to write the 1. Okay? All right. A squared over a to the -1. Well, a is going to end up here, and 2, remember we subtract exponents when we divide, so 2 minus -1 is 3. So that's going to be a to the third. B to the fifth over b to the sixth. Well, that's B. We've got more B's down here, and so 6 minus 5 is 1. So this is just going to be B. And then I have more C's up here. -1 is bigger than -5. So let's go ahead and subtract. -1 minus -5. That's going to be -1 plus 5, which would be 4. Okay? All right, so all of this in here simplified to this. Now, we still have to take it to the third power. So it looks a lot easier to do this, but you could do however you wanted to. All right, I'm just telling you, there's actually a lot of ways you could do this problem. As long as we get the same answer and you're doing the steps correctly, you're going to get the right answer. All right, so everything goes to the third power, and when we take powers to powers, we multiply. So this becomes a to the ninth, 3 times 3 is 9, c to the 12th, 6 to the third, and b to the third. Now, everything else is good except 6 to the third. So a to the ninth, c to the 12th, 6 to the third is 216. Because you know that you can do 6 times 6 is 36, and then 36 times 6 would be 216, and then b to the third. Plus, 6 to the third is on your list of cubes and squares, right? So you can look that up too. All right, this is our final simplified answer. All right, number 12. So we are looking here. I have a radical in the denominator. I don't like that, and it is separated with a plus or a minus sign. So I'm going to have to use my conjugate trick. Okay. So that means I am multiplying both sides by the square root of 6 plus 3. Square root of 6 plus 3. And when I say both sides, I mean numerator and denominator. So just like before, I'm going to write it bigger. Square root of 6 minus 3 times square root of 6 plus 3. And then I have to do 2 times square root of 6 plus 3. Okay, now distribute. Square root of 6 times square root of 6, we've talked a lot, is 6 because 6 times 6 is 36. Square root of 36 is 6. All right, then this becomes plus 3 square root of 6 minus 3 square root of 6. And then -3 times -3 is positive 9. So again, we did it right. These middle terms cancel out. That's why we use conjugates, because now we got rid of the radicals down there. And so 6 plus 9 is 15. This becomes 2 square root of 6 plus 6. Okay, and so what I'm going to do is I'm going to rewrite it with the whole number leading. So 6 plus 2 square root of 6. And just like with our eyes, we can separate this out. I messed up there. Sorry, that should be a minus 9. 6 minus 9. So this is not going to be 15. This is going to be -3. Sorry. You guys probably caught that and I didn't. Okay. All right. So we can separate this out just like we did up here. Okay. So I can look at this as 6 over -3. And then this will be minus 2/3 square root of 6. All right. I can reduce this. So that's -2, but I cannot reduce this. And so you can leave it like this. Okay. Remember, this is also a fine way to leave it. There's nothing wrong with that. So if it says to simplify completely, you might want to take it down to here, but be able to recognize all the forms. All right. 13, let's go ahead and multiply. This is just laws of exponents. So it's not distributing because none of this is separated by pluses and minuses. I'm just trying to show you that we multiply what's the same. So 5 times 15 is 45. A times a squared is a to the third. B times b to the -1, well, that's b to the 1, right? And we add exponents when we multiply them. So 1 times -1, or 1 plus -1 is 0. And b to the 0, anything to the 0 power is 1. So we don't have to write the b. That's our final answer. All right, 14, be careful. We're looking at cube roots now. So we're going to do the same thing. We have to have the same denominator or the same radicand, but we're looking in terms of cubes right now. So this is going to be the cube root. We need a cube that goes into 32. So that's going to be 8 times 4. I can take the cube root of 8 out, which is going to be 2. And so 4 times 2 is 8. cube root of 4. 32, I can do that as well. And it's the same thing. So let me do it this way, and then I will tell you what you could do differently if you wanted. Cube root of 8 is 2, cube root of 4. 8 minus 2 is 6, so we have 6 cube root of 4. Now, sometimes I get so lost in the process that I don't actually look at the problem before I start. These were both cube root of 32. And so if you wanted to first, you could put those together. That would be 3 cube root of 32. Now, you would still have to simplify it. And you would still simplify it the way we did. It's just that would be a different way of getting around there. So you would say, okay, this is 3 cube root of 32, simplify it the way we just did right here, bring out the cube root of 8, you would still end up with the same answer. So I didn't want you to be like, wait, why didn't we do this? You could do that because these happen to be the same, but you would still have to simplify, and you would still get this. Okay? All right, I to the 18th. Well, I can take I to the 16th because that would be 4 groups of 4, so I know that's equal to 1, which leaves me with 2 more, an I squared, and that is -1. So 1 times -1, this simplifies to -1. All right, 16. Again, I don't like radicals in the denominators, so I'm going to do 4 minus square root of 5 on both. 4 minus square root of 5. Okay, I'm going to write it bigger. So I have 4 plus square root of 5 times 4 minus square root of 5, and 3 times 4 minus square root of 5. Okay, all right, let's multiply. 4 times 4 is 16. Minus 4 square root of 5 plus 4 square root of 5, and then minus 5, because that would be square root of 25, which is 5. And then again, we did it right. Our middle terms cancel out, which means we're done with the radicals in the denominator. And so this will become 16 minus 5 is 11 in our denominator. And so this is going to be 12 minus 3 square root of 5. And we cannot simplify that. 12 minus 3 square root of 5. And we really can't simplify. So like up here, I knew that I could simplify these two, which is why I broke it apart to help me simplify those. But I can't, like nothing, these won't simplify, these won't simplify. So we can just leave it like that. Okay. All right, 17, another one that's just your i's. So we've got I square root of 50. I, sorry. Okay, I square root of 50. Well, how many groups of 4 can I take out of 50? Let me see. I've got I to the, obviously 40. Then I'd have 44. Then I'd have 48. I can take 48 of those. That's 12 groups of 4, right? 12 times 4 is 48. Which leaves me with I squared, okay? And we know I squared is -1. So 1 times -1 is -1. You got lots of -1s today. All right, look at this. All right, this is multiplying. So before you jump in and do anything, you have to ask yourself, what am I actually doing? Okay, we are multiplying. So let's go ahead and, so like we've talked before, you can multiply first and then simplify, or you can simplify and then multiply and check to see if you can simplify any more. So what I'm going to do is these numbers are going to stay relatively small. I'm going to go ahead and multiply and then simplify. 8 times 9 is 72. A squared times a to the 4th is a to the 6th. B times b squared is b to the 3rd, and c to the 3rd times c squared is c to the 5th. All right, so now what I did is break it apart into perfect squares. All right, 72 is, let me see, well, we've done this one before, 36 times 2. Okay, now a to the sixth, can I take that out? Now remember, when we have exponential numbers, we're just dividing by the index here, and I can. 6 will divide by 2, so a to the sixth can be a perfect square number. So I can take the square root of 36, I can take the square root of a to the sixth, but I can't with b to the third. So I'm going to say that's b to the second times b, and I can take the square root of b to the second. Okay, and then same thing with c to the fifth. I can take c to the fourth, which would leave me with 1c. So these are the ones circled that I can take the square root of. So let's take the square root and take them out. The square root of 36 is 6. The square root of a to the sixth would be 6 divided by 2, which is going to be a to the third. The square root of b squared would be 2 divided by 2, which is just b. And then c to the fourth, 4 divided by 2 is 2. So that's going to be c squared. And then we write the leftovers underneath. 2b c. There we go. All right. Another one. Here we've done a lot of these, but these have all involved radicals. This one is our first one in a while that has involved an I. It's the same thing. I don't like i's in the denominator, so we're going to have to multiply numerator and denominator by 2 minus I. So I'm going to write it bigger so you can see what's happening. So I have 2 plus I times 2 minus I, and that's I times 2 minus I. Okay, and so let's go ahead and do this. 2 times 2 is 4. 2 times negative I is negative 2I. I times 2 is positive 2I. And I times negative I is negative I squared. So that is 4. I'm going to have to come up here. There's not much space in these problems. Okay, I know that this is a negative 1, so that's a positive 1. These canceled out, which is what I wanted to happen. And so I have 4 plus 1, which means I have a 5 in the denominator. Okay, this is going to be 2I, and this will be minus I squared. So of course, again, this is going to be a positive 1 because negative 1 and the plus 2i. Now, again, when you look at it, you can see that the 1 and the 5 will not reduce, and the 2 and the 5 will not reduce. So you can leave it like this. You could even break it apart if you wanted and say that is 1/5 plus 2/5 I. Yeah, both of those are acceptable. All right, number 20. So here we've got a lot of things going on. We are multiplying, and we are just multiplying things. And remember, we are adding exponents. This is one I think where you guys messed up a lot on the quiz, right? So 2 times 3, we can do that. That's 6. A to the third times a to the 3/4. Well, let's go off to the side and do some stuff because I have to do 3 plus 3/4. I'm not multiplying, okay? I am adding. Try to keep this separate. And so we can make that. We can do this. So 1 times 4 is 4. So 3 times 4 is 12. So this is going to be 15/4. Okay, so we're going to get a to the 15/4. And then b to the 2/3 times b to the 6th. Well, we have to do the same thing. We have to add 2/3 plus 6. So let's make 3 our denominator. We didn't change 3, so we won't change 2. 1 times 3 is 3. 6 times 3 is 18. So that's going to be b to the 20/3. Okay? All right. And that's really it. Okay? It can't really do a whole lot than that. Now, if you wanted to write this as like the 4th root of a to the 15th and the cube root of b to the 20th, I mean, I guess you could, but that looks a lot messier, so we can just leave it like that. All right, I to the 29th, let's simplify. Well, I know I can do 28 because seven groups of 4 is 28, which leaves me with one more I left over. This is 1, this is just I, so my simplified answer is I. 22, we are adding or actually we're just subtracting on both of these, but we have to have simplify it in the best way we can before we move on. Oh, hey, look, square root of 81 is 9. Oh, hey, look, square root of 4 is 2. Now, this one is not a perfect square, so we need to simplify that because that's going to be 4 times 2. Square root of 4 is 2, so 2 times 2, that's going to become 4 square root of 2. So 9 minus 2, we can do the math with the numbers that don't have a radical. And remember, this one's like 4x, right? So we can't do 9 minus 4x because, or we couldn't combine the 9 and the 4 because that would, like you're treating them like variables. Since this one has a square root of 2 attached, we cannot do like we can't do 9 minus 2 minus 4. This one is not a like term with these, okay? We can do 9 minus 2, which is 7, and we can leave the square root of 4, or 4 square root of 2. So that's as simple as we can get that one. All right, number 23. So we have right here, this is just a big old mess. So we need to get rid of the I in the bottom. It is being separated with a plus or minus, which means we have to do the conjugate. So 3 minus 4i, 3 minus 4i, and I'm going to write it bigger because you know I do. 3 plus 4i times 3 minus 4i over 2. Ooh, this one's the first one where we got to double distribute in the numerator. Okay, so let's go ahead. 3 times 3 is 9. 3 times negative 4i is negative 12i. 4i times 3 is positive 12i. And 4i times negative 4i is negative 16i squared. Okay, these cancel out, which is why we do the conjugates. And negative 16i squared is negative 16 times negative 1, which is positive 16. So 9 plus 16 is 25. Okay. All right. In the numerator, 2 times 3 is 6. That's negative 8i, negative 3i, and positive 4i squared. So this is actually going to be negative 4 because we know that's negative 1. So 6 minus 4 would be 2. And this will not cancel, right? Negative 8i minus 3i, we can just combine them together, and that's negative 11i. So we can, let me make sure I did that right. 3 plus 4i. Mm-hmm. Okay. Yep, that's right. So that is, I always watch my signs. I always get myself paranoid about the signs. So this will not reduce, this will not reduce. This is an okay answer, or you can break it apart. There you go. Okay, we are to the calculator allowed part. So woohoo, here we are. Okay. Remember, guys, this is a long review because we're giving you lots of practice. So the more you practice, the better you'll be. So you will never regret doing all of this. It's a lot of work. It's a lot of work for me to make the video, but I do it, okay? Like I want to explain it to you, and I hope you guys are using this. So it says determine if this is a factor of this using the remainder theorem. Now remember, using the remainder theorem means all we're checking for is r equal to 0. That's what we're looking for. So if it's asking us if it's a factor, let's solve this. So we have 2x plus 7 equals 0. Subtract 7, that's where you guys mess up a lot. So we get 2x equals negative 7, divide by 2. So I know that x is negative 7 over 2. Okay, and then all we have to do is plug in to this. So, but you have to be careful. We're using your parentheses because it's a negative 7 over 2, but you are just substituting that in every single time for your x. All right, so you have to plug that in exactly the way it appears, because otherwise it's going to mess up. So double check, triple check, make sure you're good. And so if you put all this in, you get something like negative 895.3. Oh, that's an ugly number, but it doesn't matter because what we're looking for is zero. And so is it a zero? Is it not? Obviously it is not a zero. So since it's not zero, is this a remainder? We say no. So we say therefore 2x plus 7 is not a factor. Okay? All right, so divide using long division. So we have this divided by this. Now, what you need to check, and I also sometimes get bad about checking for it, is we're taking this is going to go in the house, right? And we need to make sure we have every power of x represented. So we have x to the third, x squared, and I don't have just a regular x, and I'm going to need that. So let's, when we write this down, 4x to the third plus 2x squared plus 0x minus 10. And then we are dividing by x squared plus x minus 3. Okay, now this looks overwhelming, and it's not if you take it slow. We are going first terms only. Okay, first terms only. I'm not looking at all this other junk back here right now. I don't even care about this junk right here right now. I'm looking at first terms. And so remember, when we are doing long division, our first step is to divide. Then we multiply. Then we subtract. Then we bring down. And then we repeat. Okay, it's just like fifth grade all over again. So let's divide. How many times will x squared go into 4x to the third? Well, some of you have a hard time imagining that, and so go off to the side and actually write it out. 4x to the third divided by x squared. Well, you can see that the x squareds cancel with the x to the third, and there's an x left up here. There's nothing to cancel with the 4, so 4x is what's left. Okay? All right, now, so we divided. Now we multiply. 4x times x squared is 4x to the third. 4x times x is 4x squared. 4x times negative 3 is negative 12x. All right, all I did was multiply. I had to multiply by all three terms, but it wasn't difficult, okay? All right, so I multiplied. Next step is to subtract. Now, I'm subtracting all of these, okay? So I am subtracting the 4x to the third. I am subtracting the 4x to the squared. I am subtracting negative 12x, which means I am adding it, okay? Now, let's do the math. 4x to the third minus 4x to the third is 0. 2x squared minus 4x squared is negative 2x squared. And 0 plus 12x is plus 12x. Okay? All right. Now we subtracted. Now we bring down. All right. And now we repeat. Divide first terms only. If you can't do that in your head, go off to the side and write it out like a little baby divide problem. Negative 2x squared divided by x squared, you can see that those cancel out and you're left with negative 2. Okay, now we multiply. Negative 2 times x squared is negative 2x squared. Negative 2 times x is negative 2x. Negative 2 times negative 3 is positive 6. Now we subtract. So I have to subtract a negative 2x squared, which means it's going to become a positive. I have to subtract a negative 2x, which means it's going to be a positive. I have to subtract a positive 6, which means it's going to be a negative. Okay? Now we do the math. 2x squared plus 2x squared went away. 12x plus 2x is 14x. Negative 10 plus a negative 6 is negative 16. Okay, now it tells me my next step is to bring down. Do I have anything to bring down? Nope. So I am done. This means I have a remainder. Okay, so it's ugly, but we have to write the answer still because it doesn't ask us what the remainder is. It doesn't ask us if it's a factor. It just tells us to divide. So my answer is 4x minus 2. And then remember what we did with the remainder? We just put plus, and then we have 14x minus 16 over what you divided by, x squared plus x minus 3. And that's what you do all the time. Is there a lot to it? Yeah. But is each step difficult? Nope. It's just there's a lot of steps to remember, but if you write it down, it helps you. Okay, number 3, provide a complete graph. Remember, a complete graph means you need to be able to see all the highs and lows and state all the things about it. Well, all we're really interested in is the number of zeros. Now, I know how many zeros there should be just by looking at this. There's 5 of them, right? Now, I need to use my graph to help me how many the real zeros are, and I need to, then that can help me answer the imaginary. So what we're going to do is we are going to put this in our graph exactly the way that it appears, and then you're going to mess with the window enough until you can see all the highs and lows and all the things that are happening. And you may have messed with the window more, but when I looked at it, I didn't feel that I had to mess with the window. So I left my window on a standard window. And this is what I saw. The best that I can do. It kind of looks like that. Okay. And so we can see, now remember, the real zeros are the x-intercepts. Like, where is it crossing or touching the x-axis? Here's a real zero. Here's a real zero. Here's a real zero. Okay, so it doesn't just have to cross, it could just touch it. And so we can see here that we've got 3 real zeros, which means that we have 2 imaginary, because 5 minus 3 is 2. And that should make sense. Remember, imaginary zeros only come in pairs. And so that's what we used our graph for to answer that question. Okay? All right, number 4, it says write a polynomial function in standard form so that it has this. Now, this one always messes you up because you keep, like we have been factoring for so long that you keep thinking you want to factor. We're actually going backwards, okay? So what we are looking for is I am looking for the zeros, and then I'm going to write these as factors, and then I'm going to multiply it out to get a full expression. Okay, so what factor is going to give me negative 4 when I set it to 0? Well, that would be x plus 4, right? What factor is going to give me negative 3? That would be x plus 3. And what factor is going to give me 4? That would be x minus 4. I took each of these and multiplied them, or like changed them into factors. Because if I set this equal to 0 and solved it, I would get negative 4. If I set this equal to 3 or 0 and solved it, I would get negative 3. If I set this equal to 0 and solved it, I would get positive 4. Okay? Now, all we're doing is going backwards. So get out of your heads. Like, just stop overthinking. Just say, okay, I'm going backwards. I'm trying to make it into a big function in standard form. That's it. So let's multiply. We can only multiply 2 things at a time. Now, I'm going to pretend this x minus 4 isn't here right now, and we're just going to multiply that. So that's going to be x squared plus 3x plus 4x plus 12. I can simplify some things, and so I have x squared plus 7x plus 12. Okay, so this, when I multiplied, became this. I still need to multiply by x minus 4. All right, so I have a lot of things to multiply. It doesn't make it any different though, okay? X squared has to be multiplied to everything in those parentheses. So x squared times x is x to the third. X squared times negative 4 is negative 4x squared. Now, 7x has to do the same thing. 7x has to be multiplied to everything. 7x times x is 7x squared. And 7x times negative 4 is negative 28x. Now the 12 has to go to everything, right? 12 times x is 12x, and 12 times negative 4 is negative 48. Whew, we're done with our multiplying. The last thing we have to do is just put some stuff together because we can simplify this. X to the third. Do I have any other x to the thirds? Nope. Okay, I'm going to cross it out because I dealt with it. X squared. Okay, so I've got a couple here. Negative 4 plus 7, that's going to give me 3x squared. Negative 28x plus 12x, that's going to give me negative 16x. And then can't do anything with the negative 48, so I'm going to leave it. Guys, this is it. Now, up until we learned this, I was giving you this, asking you to factor and come up with the factors, and you would work your way down and say this. We're just going backwards, okay? All right, number 5, determine whether it is a factor using long division. Oh, so we have to use long division because it said, okay? So we are still just determining if it's a factor by looking at the remainder, okay? So let's make sure before we write it down that all powers of x are represented. X to the third, x squared. Okay, there's no x, so I'm going to have to put that in there. So we've got 2x to the third minus 7x squared plus 0x plus 11. And then I'm going to divide by x minus 4. Now remember, we divide, we multiply, we subtract, we bring down, we repeat. Dad, mother, sister, brother, rover. However you remembered it in 5th grade, right? But we divide first terms only. So we're trying to figure out how many times x will go into this. But what we're really asking ourselves is what is 2x to the third divided by x? If you cannot do this part in your head, you must write it down. It's not difficult. You're just refusing to write it down because then you can't see what's going on. The x's cancel, or like the x to the third and the x, we can subtract their exponents. And so we are left with 2x squared. So that's what I got, 2x squared. All right, I divided. Next step is to multiply. 2x squared times x is 2x to the third. 2x squared times negative 4 is negative 8x squared. Now I subtract. Change the signs is what you do when you subtract, and then do the math. Those cancel out. That's what I want every single time. Those first terms should cancel. Negative 7x squared plus 8x squared is 1x squared. And then I bring down. Even if it's a 0x, I'm going to bring it down. First terms only. Divide. X goes into x squared, or x squared divided by x is x. Okay, now we multiply. X times x is x squared. X times negative 4 is negative 4x. Now we subtract. Change the sign. X squared minus x squared. 0 plus 4x is 4x. Okay, and then I bring down. So first terms only. How many times will x go into 4x? Or what is 4x divided by x? And hopefully we can see without writing it down that it would be 4. Multiply. I ran out of room, so I'm just going to bring it up here, 4x plus 11. Okay, 4 times x is 4x, and 4 times negative 4 is negative 16. Now we subtract. 4x minus 4x is 0, and 11 plus 16 is 27. Do I have any more to bring down? Nope. So that means my remainder is 27. So what does that tell us? The question is it a factor? And we had to use long division to figure it out. If I have a remainder, this is not a factor. So all I have to say, I would identify that as the remainder, and I would just say, therefore, x minus 4 is not a factor because there is a remainder. And we can't just say it is not a factor because it says explain why or why not. So you just have to say there is a remainder, so it's not a factor. If you happen to get something that had no remainder, then you would know that it is a factor. Okay? All right, almost done. This has been a long review. Okay, so it says determine whether it is a factor using long division. It's the same thing. We put a lot of long division on here because you guys need a lot of practice with long division. Don't avoid things that you find challenging. Face them head on and figure it out. Okay? All right, so first let's make sure every power of x is represented, and of course it's not. They do this to us all the time. So we have x to the third plus 7x squared plus 0x plus 14, because I have to have every power of x represented. And then I'm going to do x minus 2. Okay? Divide, multiply, subtract, bring down, repeat. First terms only. X goes into x to the third. In other words, x to the third divided by x. That's going to be x squared. All right, then we multiply x squared times x is x to the third. X squared times negative 2 is minus 2x squared. Now we subtract. That just means change the signs and then do the math. That cancels. That's what we want every single time. 7x squared plus 2x squared is 9x squared. Bring down, and then we repeat. First terms only. 9x squared divided by x. Well, if you cannot see that in your head, write it down. X squared divided by x is just x, and there's nothing to go with the 9, so this becomes 9x. That's what we write up here. Now I multiply. 9x times x is 9x squared. 9x times negative 2 is negative 18x. Next, we subtract. Change the sign. Cancels out, and this becomes 0x plus 18 is 18x. And all right, and then we bring down. So I still got this 14. All right, first terms only. 18x divided by x. If you can't see that, write it down. You can see the x's cancel, and I'm left with 18. Now we multiply. 18 times x. Ran out of room. 18x plus 14. Okay. All right. So 18 times x is 18x, and 18 times negative 2 is negative 36. All right. We are subtracting, which means we change the signs. And so now this becomes 0, which I won, and 14 plus 36 is 50. Do I have anything else to bring down? Nope. So this means that 50 is my remainder. And so if I have a remainder, is this a factor? And the answer is no. So we say, therefore, no. X minus 2 is not a factor because there is a remainder. Okay? That's it. And if you happen to be lucky where everything goes perfectly, then you can say, yes, it is a factor because there is no remainder. Okay? All right, number 7, it says for 7 and 8, identify the number of zeros and what types of zeros are in the given expression. So we are doing the same thing as the one we did before where we had to sketch a complete graph. We don't know this until we actually look at it in our graphing calculator because this is our calculator section, right? Now, I can look at this and know that there's 5 total zeros. But what I need you to do is use your calculator. Put this in your calculator. You can see once you look it up, and if you need to mess with the window, go ahead. But as you look it up, you can see that there are 3 spots that either cross or touch the x-axis, okay? Which means there are 2 imaginary, and you always need to think, does 2 make sense? Yes, because remember, imaginaries only come in pairs. So this makes sense. Okay, now number 8, you can look at this and you can see that there should be 3 total zeros and put it in the calculator. How many times does it cross or touch the x-axis? The number of times that it crosses or touches the x-axis is 3. So what does that tell us about our imaginary zeros? There are 0 of them. Okay, that's it. So sometimes it asks you to draw a complete graph, other times it just asks you use a calculator. Okay. All right, number 9, determine if it is a factor using the remainder theorem. Oh, hey guys, we're in our calculator section. If it doesn't tell us to use long division, don't use long division. Okay, so what we can do instead to make it easy on ourselves is solve this. And so I know x is going to be negative 5. And let's just plug it in. Okay, now you do have to be careful. That is a negative, so use parentheses. It is a lot. Okay, they make you plug in things a lot because they're hoping you're going to make a mistake. And so if you plug it in and check it, I would even do it twice or double check on the screen that you have done everything correct. And so what we get here is when you put all this in the calculator, we get 0. So that means our remainder is 0. So what does that tell us? So we say, therefore, x plus 5 is a factor because r equals 0. Okay. Um, yeah, guys, this is a long review. We practice a lot to make sure we are good. And then when the test comes, it's not that big of a deal. Okay.